This is a tutorial video about rotations. The first thing you need to do is take out a little sheet of paper and copy down these notes. These are the rules of rotations, and I'm going to be using these throughout the video. So you want these rules to be on a little piece of paper sitting right next to you when you take the quiz. First of all, real quick, what is a rotation? Now you're probably familiar with a rotation in terms of something spinning around like this. Okay, you could think of that as a rotation. But in this tutorial we're going to talk about not something rotating around its center like I was just doing, but instead we're supposed to imagine somehow this heart rotating around the origin. So you have to imagine that this heart is going to take some sort of a path around the origin like this, and it might stop at different places along the way, and depending on where it stops, we'll be talking about a certain number of degrees. Now if the heart rotated from here to here, that is a 90-degree rotation. Okay, just moving 1/4 turn is a 90-degree rotation. If we did it again, now we've gone 180 degrees, or you could think of it as we did 90 degrees twice, and that's 180 degrees. If we rotated one more time, now we have rotated 270 degrees. Now if I rotated one more time, that's going to take me all the way back to where I started from, and of course that would be a 360 degree rotation. Now this is called counterclockwise, alright, the direction that we're going in, because it's the opposite direction that a clock turns. And so all of these are positive motions. If you go the other way, alright, if we had gone this way around, like from here to here to here, in this direction, alright, if we went clockwise, then those would be negative motions. So a 270 degree rotation is the same thing as a negative 90 degree rotation, alright, because now we're moving this way. 180 degrees and negative 180 degrees would be the same thing. If I kept going in the negative direction, this would be the same thing as negative 270 degrees. And of course this would be the same thing as negative 360 degrees. Alright, so you just need to understand that this direction, clockwise, is the negative direction, and this direction, counterclockwise, is the positive direction. So when you look at these rules, so I have these rules for a 90 degree rotation, a 180 degree rotation, and a 270 degree rotation. But notice, next to 90 degrees off to the side, I say negative 270. A positive 90 degree rotation is the same thing as negative 270, and so on. Now real quick, what do these rules mean? The rules mean, alright, take a 90 degree rotation. If I had the point 2, 3, and I rotated that point 90 degrees around the origin. This rule says that the x and y will switch places and the y will change signs. So the x and y will switch places, so the 3 will go here and the 2 will go here, but the y value has to change signs, so it would become negative 3, 2. Now let's say this, let me do an example that has some negatives in it already. In fact, let's look at 270 degree rotation. Say if I had the point negative 3, negative 5, and there was a 270 degree rotation. Okay, this rule says again we're going to switch the x and y, but this time the x value has to change signs. Alright, so I have to switch the x and y, so my y value is going to come over here, and my x value is going to go over there, But this negative sign doesn't mean that it's going to be negative. It means it's going to change signs. So my x value has to change signs. So instead of -3, I would have to put a +3 right there. Okay, and this ink is a little too thick. Gotta calm it down. Calm down. So one more example. Say if I had -4, 7, and I were doing 180-degree rotation. Well, in this case, you don't switch anything around. You just change the signs. So this would be +4, -7. That's what these rules mean. All right. Make sure you have them copied down. I'm going to use them a lot. I'm going to kick this up one notch. All right, let's do 6 problems. One vertex of a polygon is located at 3, -2. After a rotation, the vertex is located at 2, 3. Which transformations could have taken place? Check all that apply. Okay, so let's see what happened. The original point was 3, -2. And then the new point was 2, 3. Okay, basically we're looking for which rule happened. Did they switch places? Yeah, they switched places. The 2 and the 3 switched places. That means it can't be the 180 degrees because that's not switching places. So it's either going to be the top one or the bottom one. So now something changed signs. Was it the x value or the y value that changes signs? It is the y value that changed. Alright, the -2 became a +2. So look for the one where the y value changes signs. Is it this one? Nope. Aha! It's this one. The y value, this negative sign tells me that the y value changes signs. So we must be dealing with the top rule. Okay, we must be talking about a rotation around the origin that is 90 degrees. But wait! These go in pairs. 90 degrees is the same thing as -270 degrees. Okay, so this would be the same thing as -270 degrees. So I'm going to look down my list. If I see either of these, I'm going to check it off. Oh, look, there's a rotation of 90 degrees. Nope, nope, nope. Oh, down here at the bottom, -270 degrees. Those go together. So those should be the answers. Let's see what's up. Bam! That's how you do that, my friend. Okay, let's keep going. I'm going to drag these rules around with me so I can use them again. Okay. Let me get these check marks out my face. Alright, now let's look at this next one. A pentagon is transformed according to a rotation of 180 degrees. What is another way to state this rotation? And then they got a bunch of rules. Well, just look up for the rule that goes with a 180 degree rotation. It's right here. -x, -y. So that's this one right here. Alright, so that's it. Oh my goodness, do you see how easy this is? All you have to do is have this little piece of notes with you when you take the quiz. Come on, everybody. You got this. You got this. This is not hard. Okay, let's keep going. One vertex of a triangle is located at the point 0, 5. Be careful with the 0. Is there such thing as -0? No. -0 is still 0. So when we do these little things where things are changing signs, if it's a 0, you won't be able to tell. Alright, so watch out for that. Anyway, what was I saying? One vertex is at 0, 5. After transformation, the vertex is located at 5, 0. Okay, so 0, 5 became 5, 0. And again, they're asking us which transformation happened. Alright, first things first. Did things switch sides? Yes, 0, 5 became 5, 0, so definitely the x and y switched places. So again, that means it can't be the 180 degree rotation. So it's either the top one or the bottom one, or both. So now let's see what the deal is. Now, did anything change signs? Well, maybe. So both of these rules involve things changing signs. But here, I don't see any signs changing. So look at the 5. Obviously, the 5 did not change signs. So the x value, sorry, this is the y value. The y value did not change signs. So that means this one right here, where the y value changes signs, can't be it. So it can't be 90 degrees, you know, or negative 270 for that matter. Skirt. All right, because the y value changes signs. That just leaves this one. Now in this one, you see that the x value changes signs. Could that have happened? Well, yes, because the x value is 0. And like I said, 0 and negative 0 are still 0. Alright? There's no such thing as negative 0. So the 0 still could have changed signs, and you just wouldn't be able to tell. So it's okay. This rule would still work because the x value could change signs, and it would still look the same. So that leaves this. So we're talking about 270 degrees or negative 90 degrees. Okay, so let's see. So there's 270 and there's negative 90. So it should be those two. Kabam! That's how you do that, son. Alright, let's keep going. Take these rules with me. You take your rules with you as well. Keep those rules close and your enemies closer. Let's see. Do I have room for this? Let's see if I can make it work. Okay. A triangle has these vertices, and then the triangle is transformed according to a 270 degree rotation. Okay. What are the coordinates of S prime? All right, the new S. All right, this should be pretty simple. So they're saying focus on S. So point S is negative 2, negative 4. All right, that is the point S. Now we are supposed to find S prime, the new S, after a 270 degree rotation. So we are using this rule right here. And this rule says switch the x and y and change the sign of the x value. All right, change this guy. So I'm going to switch the x and y, but the x value has to change signs from here to here. So the negative 4 is not going to change signs, but the negative 2 is going to become a positive 2. Again, this negative sign means change the sign. It doesn't mean it's going to be negative. So that's it. Negative 4, 2 should be the answer. So it should be this one right here at the top. Let's check it out. Kabam! Nailed it again. Hopefully you're starting to see how easy this is, and you're feeling like you want to jump back in there and do this by yourself. Feeling confident that you can do this. Let's see. We have 2 more problems to do in this video. So triangle XYZ is rotated to create the image x prime, y prime, z prime. Okay, great. So we have the pre-image and the image. Now, which rules could describe the rotation? Check all that apply. Alright, there are different ways you could do this. If we want to use our rules, then let's look at a point and see what happened. So take the y value, for example. This y point is the point 1, 2, 1, 2. And now look at the new y value, y prime, which is over here. So it became the point, now this is the point -1, -2. -1, -2. Okay, so let's look at that again. So 1, 2 became -1, -2. So which rule is that? Did they switch sides? No, the 1 and the 2 are still in the same order. All that happened was signs changed. Well, that's the middle one, 180-degree rotation. Okay, which is the same thing as -180 degrees if it comes up. Okay, so that means this one is good, 180-degree rotation. Now I see these bottom two are rules, and one of them is the rule that we're talking about. Alright, the -x, -y. That's this one right here. So that's two different ways of describing the same thing. So these two should both be the answer. And if they had -180, that would also be an answer, but it's not there. Alright, let's check it out. Boom! Nailed it once again. Alright, we have one more problem to do. Let's drag our notes with us to help us. Okay, a little note card, loving it. Last problem. A triangle has these vertices. The triangle is transformed according to the rule rotation about the origin, 180 degrees. Which statements are true regarding the transformation? Check all that apply. Okay, now there's talking about all these letters, so I feel like we should just do the whole triangle. So the original triangle is L, alright, which is 2, 2, M, which is 4, 4, and N, which is 1, 6. Alright, and this is going to become L prime, M prime, and N prime. We're doing 180-degree rotation, so we're doing this rule right here. The x and y will not switch sides. We're just going to change the signs. That's it. So L prime should be -2, -2. M prime should be -4, -4. And N prime should be -1, -6. Now let's answer some questions. The rule for the transformation is xy is mapped onto -x, -y. Yeah, that's exactly the rule. So check mark. The coordinates of L prime are -2, -2. That is also true. Check, check. The coordinates of M prime are -4, +4. That's wrong. Alright, it's -4, -4. So, nope. The coordinates of N prime are 6, -1. Nope. The coordinates of N prime are -1, -6. Yes. So that's it. And obviously, once again, we got it right. So I hope you're feeling a lot more confident and ready to try this on your own. So good luck. Don't forget to have a little copy of your, have a little note card with you with these notes on it when you take the quiz. Good luck.